here, and I do software supply chain security and DevOps security. I'll be introducing the topic of my thesis because it's an overarching technology that pretty much helps us walk through the whole topic of supply chain security. But then I'll give point technologies and talk about what solutions are generally put in place to also further secure the supply chain, not only the integrity, but the individual elements of it. Please stop me if you have any questions, if anything is confusing, or you have like a counter idea, or you think that there's something worth mentioning, please do it. Sorry. Here. Now, probably many of you are familiar with software, and if you guys have a project or have worked in the industry, you may already know how software is made. But just for the sake of the argument, let's do an idealized software supply chain. Say that you have your code for your site project or your company's project. It's usually hosted on a version control system. Then you sometimes have a CI system that's running continuous tests every time you do a git push or a development branch is pushed or a pull request. Then you probably have a build system running on a build farm somewhere that's pulling your code, it's building it, it's probably packaging it in a Docker container, and then it's pushing it to Docker Hub or something. And then finally, this is cut, it's Kubernetes. Finally, it's everything, it's admitted into a Kubernetes cluster, and you have your application running in the cloud. Now, as we all know, if you do anything to this supply chain, if you're able to tamper an individual step in it, you may be able to compromise the whole application all the way down to the Kubernetes cluster. I'll flip through some examples. You probably have heard that the Free Software Foundation's repository got hacked once, that the OpenAX hat server got a backdoor implanted on it. SFTP was also hacked into the version control system, and the backdoor was put in it. There was some allegations that the FBI actually hacked into the OpenVSD IPsec stack just to introduce a backdoor.
So SFTP, is that secure FTP?
Yes.
Yeah, so secure FTP.
Yeah.
Ironic.
Imagine that. And that's the thing. Security products generally make people feel comfortable about it, create this fake sense of security. And then you do this, and now everyone's just running with an insecure version of the software. Juniper, the firewall vendor, I don't know if you heard of this one. This was a really big one. Some people even claimed the NSA did it. Someone hacked into the version control system of the Juniper firewalls that also have an IPsec VPN server capability, and just changed the number of the pseudorandom seed generator to a 4. So anyone that knew about it was able to figure out and decrypt the traffic that was being run by those VPNs just by hacking into the version control system. That's why it's so important to protect the whole software supply chain. The Linux source code repository was also hacked. Another FTP server, ProFTPD, was hacked. And by the way, this is only hacks into the version control system. I'll give more context. Build servers have been hacked too. There's this concept of backdooring compilers that have existed as a theoretical issue, and now they're part of the reason why we have this reproducible builds initiative to make sure that there are no hacks, no backdooring compilers within the stack. I don't know if you guys heard of Xcode Ghost. I actually think the geometry of the screen is different from what I had thought. Xcode Ghost was a backdoored version of Xcode that made any app that was built using this backdoored version of Xcode have another backdoor. So about 1,000 apps that were published in the App Store had a backdoor put in it just because there was a compromised version of Xcode running around.
Everyone's familiar with the idea of a backdoor? So this is a way that a hacker puts to get into the software, not coming into the front door. They've got their own secret entrance into the software.
Yeah, there's a famous there's a famous backdoor on Cisco routers. I think it was John backdoor or something. It was the name of a developer. So he put an actual if clause into the authentication system that if you put the username as his name reversed, you would be able to log in without a password. And that made it to like many Cisco routers until someone actually pulled the firmware and started analyzing the code, and he found the clause and then found the name of the guy, and of course he got in trouble. But yeah, that's like a very famous backdoor. Fedora, FreeBSD again. On packaging, you also have this famous botnet that was created. They hacked into the Linux Mint servers. They introduced the code to make it be like this Linux Mint installation specifically become part of a botnet. So about 800 people downloaded Linux Mint that day. It was only for a day. And they created an 800 node botnet just out of the box. Kingslayer was another famous one on CCleaner. PHPMyAdmin was also hacked. Red Hat again. And well, there's also cases in which you, for example, don't listen to your CI/CD system telling you, hey, something's broken, don't push this update. It actually happened to Windows again about a week ago. I don't know if you guys had that update that really broke your system for a little while. That was because they didn't actually test it. And it updated, it broke some people's setups, and then they had to like really quickly roll back the update before like it started breaking more people's software. So that's the thing. So far in our idealized 4 or 5-step software supply chain, we're able to see about 30-something like major profile hacks. And the reason as to why they're so major profile is because once you break into this like little version control system, all of the users are compromised. Once you break into the build system, all of the users of that software are compromised. The same goes for packaging. Testing is a little less widespread, but you can do these things. And this is only if you hack into the step. Now, there's other ways that attackers can compromise your supply chain, and that is hacking into within the steps. Also, like tampering things as they travel between the version control system and the build server, for example. Or, for example, cutting the line of communication here so the test suite doesn't detect something was wrong on this build, and so on and so forth. Now, again, this is on the concept of my thesis, but it'll help you like figure out exactly what we need to fix. Now, to fix this, then we need to first of all start thinking about compliance. How can we enforce compliance, and how can we enforce good practices? But before we go to do this, I wanted to like give a little bit of just a quick overview of how you can secure individual steps. Again, the supply chain is a chain, and the chain is as strong as the weakest link. So you generally want to first secure all of the individual links, and then secure the supply chain as a whole. In this case, for example, Git has a couple of technologies that you probably have heard before. Git signing. That's if you sign your commits, you can actually attest cryptographically that the software that you pushed into your version control repository is actually made by you. So if a hacker gets in and he introduces a new version, as long as he doesn't have control of your cryptographic key, think of it as two-factor authentication of your code, he's not able to change things. There's other solutions. Actually, I worked with the Git community to fix some of their security model. That was a paper that I published in 2016, and then a paper into HSCCS. There's also a solution that's not very known of on Git. It actually exists. You can use it. It's called Git signed push. That's something that I encourage you guys to start looking for. The reason why signing is not enough is that the state of the repository is not signed itself. So for example, I'm also an Arch developer. And something that I found out is that you can essentially move around these files. You probably have seen it if you use Git today. And teleport, something that's called a tag teleport. And you can trick a build system to build the wrong tag. Or you can trick a build system to build an old vulnerable tag. And even if you sign that tag, the verification is going to pass because it is actually signed. It's just signed. It's an old signed tag, a tag that exists, a tag that was correctly signed back then, but it's not the tag that you wanted to build. So we fixed this in Linux, in Arch Linux, and we fixed this in Git back in version 2.9. You can start doing Git signed pushes today, and you can start pulling something called push certificates that tell you exactly what was the state of a repository when you pushed and tagged things out. For build systems, you can have TPMs and HSMs that are trusted platform modules and hardware security modules that can help you build like a stack of known versions to work, so you know that the operating system is correct, that the packages that you build on top of it are correct, and hence the whole build farm is correct. You can also use reproducible builds, which is the probability of backdooring many compilers across 5 different computers distributed across the globe using different stacks is way lower. So you, for example, could use push certificates to secure this, and then distribute the build to different people or different build farms, different infrastructure to make sure that the backdooring compiler is not existing on all of them. If all of the builds are not the same, then you know one of them probably did something fishy. One of them, or maybe 4 out of 5, or you get the idea. And finally, you can use things like TLS, GPG, TOF, the update framework, Notary for the cloud-native solutions to secure the pipeline in what's called the last mile. In this case, for example, you want to make sure that the person who packaged it is the right person who packaged it, and that the version that you wanted to retrieve in a very similar way that happens with Git is the one that you wanted, and that, for example, that the package is not stale. Something that happens is that hackers break into this part of the repository and then they start shipping old versions of the package. That actually, we did this at NYU back in 2013. We registered a Debian mirror. It was old, and it was sending, again, the correctly signed packages, but they were a couple of years old, and they had known vulnerabilities to exist. So you not only give the package to the people that's an old package that's vulnerable, now you also know that they have a vulnerable package, and you know which vulnerability do they have. So you can essentially exploit them right away. Of course, we did this for research. We did everything ethically, but this can happen. Well, this could happen today. That actually, this was part of the update framework, and that's part of the reason many Linux operating system package managers changed. This resulted in a bunch of papers. This is kind of part of the standard. You have different levels of trust for different packages, and you have expiration dates on packages, and so on and so forth. And it has been standardized in many things that you use today. If you use Python, there's a standard being written. If you use CoreOS, that's using Quay. If you use Docker, that's using Notary. If you use Flynn, that's the update system. For Cloudflare, we actually found out that we had a typo in the logging message. And then we started grepping for logs in a Cloudflare machine. And we realized that they were running TOF. We just didn't know it. They never told us. Huh?
You were running what?
We were grepping for logs. We were analyzing logs in a machine that was in Cloudflare. And we found that they had exactly the same log message that we wrote with a typo. We were using the typo to find out, within all of the different application logs, filter out the ones that were for TOF. And we also found that they also have the TOF logs in their machine. Well, in their machines. That was pretty cool. No, wait, that was DigitalOcean. Sorry, I got confused. Anyway, that's TOF is now part of the Cloud Native Computing Foundation. So I'll show you guys later. Cloud Native Computing Foundation is an organization that's trying to not exactly standardize, but help projects that are part of the cloud native ecosystem to be like more visible and to be like more widely adopted by cloud native applications. Do you guys know what cloud native is? Yes? Okay, that's awesome. So it has been audited. It's also now part of the way that your car updates. But that's not it. Even though we went to 3 different steps, and I explained how you can secure those steps, there's issues with something that I already said, things that are within. The fact that this specific image of the supply chain, you see it, but there's no way to encode it in your system unless you write a specific piece of code that tells you this should be on a Git repository built on this specific build farm on this servers across the globe, and it should be packaged in a Docker container, in a Docker image that has these characteristics. So basically we have an issue with there's no way to verifiably define the steps of the supply chain, which is this picture that we were seeing. There's no way to verifiably define who's able or authorized to perform the steps in this supply chain. And there's no guarantee that everything was happened according to the plan. You can create as much push certificates on Git as you want, but if there's no one checking for them, then you're really not getting anything out of this. The same goes for the other 2 existing steps. So basically, this is what we use my thesis for. This is what InToto does for you. The idea is that you pretty much produce something similar to a pipeline job. If you guys are familiar with Jenkins, it would be similar to a Jenkins file that pretty much says, well, these are the steps. We have a section for steps that says Git, build farm, Docker, Travis. And then it also says, well, Bob does Git, Carol does build farm, Aaron does Docker, and Dave does Travis. And it also says, well, the outputs of Git go into build farm, and the outputs of Git go into Travis, and the outputs of build farm go into the Docker image. I know this sounds very trivial, but for some reason no one did it before, and all of the compromises that we were seeing were basically the lack of compliance on the supply chain as a whole. And finally, you have a cryptographic signature that will let you attest that this is the right piece of layout, and that actually all of the things that were set here are provided by a trusted party. In this case, on the deployments that we have of InToto is the CISO of the company, it's a security audit team, it's the head of DevOps, etc. Then, now that you know what to do, the next thing that you would have to do is to actually perform the things that you do and attest that the things that you did are compliant with the requirements that were defined in this layout policy, right? In the case of InToto, you essentially use our framework and you produce attestations for each of the individual steps. You, for example, create something that's similar to a push certificate that says, I checked out and tagged this tag. And then when you do the CI system produces a piece of link metadata, that's how we call this, that says, I built out of these sources, and this was the result. The build farm says the same. I built out of the sources, and this is the binary that I created. And the packaging, in this case I used the Debian package, it says, I took out this binary, and I put everything inside of a .deb. Now, finally, you verify everything that everything's correct. You have your end user. It could be a Kubernetes admission controller. It could be a package manager. It could be you running this command that we wrote for the framework. And you essentially feed it all of the attestations of the individual steps, a policy file that says, hey, this is what should happen. And finally, the final product that you want to verify. Once you have everything and everything's correct, you know that everything was performed according to the plan, that everyone that should have performed it according to the plan, and that the thing that you have here actually follows a chain of attestation all the way to the moment in which the source code was written. Now, this is not like bragging. We have a lot of interactions. There's a lot of communities that are actually interested in what we're doing. We have deployments of this, of in total, in like all of the pictures that you see here. I'll also talk a little bit about other satellite projects that are trying to do the same and how you can use them. We actually integrated it into Datadog. I don't know if you guys are familiar with it. It's actually finally in as of Friday. So if you use the Datadog agent to like update your Datadog plugins, you're actually knowing that all of their infrastructure, all the way to the moment the developers checked in the code, follows a chain of attestation to make sure that everything was done according to the plan. Now, because this is not just to talk about my thesis, I wanted to also like give a brief overview of tools that exist that you can use to protect your cloud native ecosystem. As I said, there's the version control system and all of this, but this is not enough, especially in cloud native. You have things like vulnerability scanners. I don't know if you guys are familiar with it, but it's pretty much a container that you put within the pipeline. You feed it either a binary or, well, not a binary, a package or a Docker image, for example, and it essentially starts going through everything that's in it and says, I found this amount of vulnerabilities in the package. In the container image, it shouldn't go in. Some examples of this are BlackDoc, Twistlock, Veracode has a product, I forgot the name, but they're part of CA now. The Aqua Scanner by Aqua Security, and JFrog X-Ray. All of these are different degrees of open sourceness and different ways to actually deploy it. But it's pretty much that. You put a container that has an API that's running. It gets information about the things that you want to scan, and it produces a log output. If you were to integrate all of this, this would be similar to what you would put in the CI, like besides the CI system, and it would tell you information about the image that you just had. There's also static analyzers. You essentially run something similar to a scan, but you usually do it on binaries, on sources, or on container manifests. An example for containers is kubesec. You essentially feed it a container manifest that you're going to deploy to Kubernetes, and it tells you like, hey, you shouldn't be opening this port, or be careful because the policy that you put for C groups on this specific container is very permissive, and things like this. You can go on a similar line with like Volgrind or Cochinelle for like binary programs that say, hey, you're not deallocating the memory properly, or there's a buffer overrun on this thing. This is actually dynamic now that I think about it. Or you can also do the same for source code. You have things like Bandit in Python that say, hey, you're actually using hashlib of like Python's hashlib, and you're producing an MD5. That's a very bad idea. Or hey, you're using a try-erase construct. That's not a very good idea if you're not changing the exception at all, and so on and so forth. And finally, well, not finally, you also have pipeline managers. You guys heard that you're familiar with Jenkins CI. You essentially declaratively say, hey, something similarly to Intoto, this is what should happen in all of this pipeline. There's a bunch of plugins. We actually have a plugin for Intoto within Jenkins to essentially have it produce link metadata for each of the steps that you put in the pipeline. You also have Circle CI. That's very similar but it's closed source. It's I don't know if you can actually deploy it on prem. And then you have Heroku Flow. If you guys are familiar with Heroku, it's a weird pseudo containerized thingy. You can also use their specific pipeline managing solution to actually like streamline all of these steps. And then you have artifact metadata stores. This is similar to what Intoto does, but it generally gives you more information for auditing later down the line. For example, with Repeater, which is an artifact memoization project, you can actually, if you guys are familiar with the concept of memoization, in like algorithms, it's generally you compute some results and then store them because you know you're going to need them later. In the case of Repeater, you essentially compute all of the artifacts that are needed, and then to produce the final product, you essentially just link them together and say, hey, all of these artifacts should be put in this Docker image, or all of these artifacts should be put here and there. You can use it to essentially have like a pre-computed state of anything that you may need. There's Graphias. This is a product by Google, where Intodo is also transparently integrating with it, but it's in the way that Intodo is very descriptive about the overarching architecture of the supply chain. Graphias can tell you in a very transparent way how to interconnect the metadata on very specific cloud-native artifacts. For example, there's an integration between the X-ray vulnerability scanner and Graphias. So it actually tells you in a JSON parsable way all of the artifacts that it detected that have vulnerability, and then you can also use that in Intodo to make sure that everything's according to the plan. And then there's Sparks, which is some blockchain-y thingy that's similar to Graphias, kind of like Repeater, that you essentially build an artifact, put it in the blockchain, and now you know that it's there. Well, a pointer to it, and now you know that it's there, and it was produced by the person who claimed to did it because they have a Bitcoin address that points to whatever. You also have artifact validation. There's I don't know if you guys are familiar with, for example, Kubernetes admission controllers, but it's pretty much you have your cluster, and right before a pod comes in, or a daemon set or a stateful set comes in, it sends a message to a container that you have running, and you say, hey, this is the image. Is everything good? This is, for example, something like a perfect place to put Intodo verification. Or, for example, you can even send you an SMS and say, hey, do you admit this thing to come in? This is like an open API. Well, all of Kubernetes is open that you can use. There's also a library in Go that you can use to write your own admission controllers to essentially fit your needs. Of course, there's an Intodo library container that you can use for doing admission controlling. You put the layouts in the container, and it starts gathering all the link metadata that you built. And then finally, before the image gets into your cluster, you know that all of the attestation chain has been properly followed. And you also have artifact validation using Notary and Tough, which is this last mile solution that can tell you if it's old, if it's actually made by the person that you trust, or if it's actually revoked, like the key for it was revoked, so then you shouldn't trust it anymore, and so on and so forth. There's also this aside. There's this book. It came out 2 weeks ago, I think, or maybe even a month. It's about Kubernetes security. Wow, this is very pixelated. It's written by Liz Rice, which I think it's an amazing cloud-native container security person. And it pretty much covers a lot of the tools that I covered here. It covers more. It actually talks about my thesis and how there's all of these different things that you can use to protect each individual step in your supply chain, in your DevOps pipeline, and how you can make your container cluster more secure by doing cgroups limitations, by analyzing with kubesec and so on and so forth. You can download it from this URL. It's free. You just need to register. I don't know for how long will it be free, but you should probably download it now that it's free. And it's a very recommended read.
There's no animal on the cover.
I'm sorry?
It's an O'Reilly book, but there's no animal on it.
Yeah. I wonder if it's like fishes or something making a change. I don't know. I have the PDF, and I actually never thought about it, but it's a very good question.
It's the first O'Reilly book I've ever seen without an animal.
Yeah. That's very strange. It's a good point. I don't know. I'll have to ask the authors.
Maybe they ran out of animals.
I don't think you can run out of animals, but you never know. And yeah, well, conclusion, securing the software supply chain, as I showed, is a very important, very open challenge that we're having today. Intodo is the first tool that does it. You can use it today. There's many simple but subtly wrong approaches by the same fact that it's an open question, and you can try Intodo today. You can go to this URL, start playing around. There's also, I wanted to make an open invitation. If you guys are looking for an open source project you'd like to work on, we are more than welcoming new contributors and people interested. As I pointed out, we have people working in a Jenkins plugin. We have people working in Kubernetes plugins and admission controllers. We have a Go implementation on the going. We have a Python, Java implementation on the going for all of these different parts of the ecosystem. We have a layout tool, so you can write your layout online and have it signed and everything in a very friendly GUI. So if you're interested in working on something, please reach out to me. You can either write me an email, you can follow me on GitHub, or send me a DM on Twitter. And it would be great. If you have any questions on how to deploy it, or if you want to play with it yourself and hack on it, please reach out to me. Any questions?
Yeah, so a question on Imhotep. What's to stop, say, a hacker from just messing with the metadata?
So the metadata is itself signed by the person who does the specific step. In the layout, we put the public keys saying this person is the one that's allowed to sign for this specific piece of metadata. Something that can happen, though, is that the hacker hacks the person who owns the key, right? That's when things like threshold signing and things like this start coming into play. Say that, and that's part of the reason why this layout is important, because it's a policy and you have to assess what's the danger on certain things. Again, hacking on the test server, okay, you make the tests pass, that's not so bad. But if, for example, someone hacks the version control system or the build system, then it's a very big problem. Something we have in Toto and that you can do today is say 3 out of 5 people at least should sign and agree on the same specific artifact that's checked in. So then the hacker's job is to hack 3 people out of 5, then it becomes a little bit more complicated. That's something that goes again to the line of reproducible builds. You want to have many people build it and make sure that the hacker's job is more complicated by having this threshold signing. For example, something that we're deploying with Debian, that we're working on deploying with Debian, and it's a reproducer setup. We have people on the EFF, the Electronic Frontier Foundation. Some people from Greenpeace apparently also are interested into doing this. Here at NYU, of course, Debian. We're all getting together so we can start rebuilding packages together all the time. So at least 2 out of 4, 3 out of 4 people agree that the same Debian package that you installed is a reproducible build, and then hacking a specific actor is harder. Did that answer your question?
Yeah.
Awesome.
One of the things that, the impression I get, see if you find it's true, is that we're always in an arms race, right?
Right.
Hackers are always figuring out the newest thing you guys did and figuring out a way for that. So it's not like it could ever be done. But we have to keep trying because the hacker, trying, then everything's hackable. So the good guys develop a new step, and the hackers will figure out a way to hack that eventually. So you have to figure out the next step.
So a big issue is that and that's something that we're facing with TUF and Notary too, is, well, you have this person that signed this layout. How do you know this person is the right person who signed this layout? It's a similar issue with what happened with TLS back in the day. You have a bunch of CAs, and all of them are starting to charge to get a namespace on the DNS, on the DNS. But then there's people who actually get apocryphal certificates for a website, and then they reroute the traffic, and then they're able to SSL validate a website that's hacked. There's, for example, the case, I think it was Iran recently, that they had a fake certificate for Gmail because they wanted to intercept communications there. There's this case for China that man in the middle GitHub. So there's a saying I always say, it's insecure turtles all the way down. You make this specific, secure, very strong security solution for the supply chain, but now you have to find a way to actually distribute the keys and the trusts and the namespaces for this specific supply chain layout. That's something that's an open problem that I'm also working on, and I'm sure that once we fix that, it'll move somewhere down the line. Something that also we need to think about is, well, you have an admission controller that does in-toto verification. a hacker can try to hack that and disable that and make it pass and bypass it and so on and so forth. So how do you make it very secure? How do you make it tamper-proof? That's where it gets to read-only file systems, to something we call functionary in a box. That's essentially you buy a box that just does in-total verification with baked-in keys, and there's no way to disable it. But that's thinking future tense. We first need to secure this specific low-hanging fruit, and then start moving towards like strengthening the whole ecosystem beyond the supply chain layout.
Have you looked into NPM at all? Because I know over the summer as well, there were issues about how, because NPM packages are open source. There were a lot of cases of it getting hacked, and I never understood why, but the more I heard about your project, it makes more sense. But do you happen to know anything about?
Just have you looked into, I missed the, what have I looked into?
I'm sorry,
You said, have you looked into
NPM?
NPM?
Yeah. Well, it's a JavaScript. Like,
Oh, the JavaScript package manager.
They're also having issues with that.
Yes. They're especially difficult. Again, we've worked with PyPI, Arch Linux, and other. All of this fall into what we call community repositories, which is there's a bunch of people, you don't trust those guys, and they are able to upload artifacts. And, well, you have to trust them. And there's the issue with LeftPad. I'm sure that you've heard of it, that a guy pulled out a JavaScript package called LeftPad that essentially just padded slices. And then the consequence of that is that everyone that was building on top of it essentially got their packages broke. We've looked on it, and that's an interesting question for something that's an extension of TUF called Diplomat, which is you have different degrees of trust. If you think of all the packages in NPM, you would, for example, trust, what's the name of this? What's the name of this web server? Express? You would trust the people from Express more than some random guy that uploaded something called JS web server blah. And the reason as to why is because as a community repository and as a community in general, this trust starts building over time and by usage and by testing. So what you can do in cases like this is provide them a more authoritative view of what are the packages. So you trust the people from Express to actually tell you what's on Express, and within their namespace of Express, you can probably trust them more than some random guy down like the road that pushed something called Express Extension 1. That's in the case of NPM. That's part of what we're doing with PyPI too. It's a similar case for like all of that ecosystem.
So one of the DevOps ideas is we want everything to be rebuildable by a script or something. But there's a tension between that and the fact, so you run a Django server, so we should be able to rebuild everything from the repository. But there's certain parts of your Django server you want to keep hidden. You can't put it in your repository.
Right.
Is there a well-known solution, something like this gets encrypted on the way in and decrypted on the way out?
Yeah, so there's a bunch of pieces on that specific like path. There's HSMs for like key storage and all of this. Like a big mistake is to put your SSH private keys on GitHub, right? And on that note, you can put things on the HSM and then authenticate them once deployed and then pull them in. There's things like Jenkins, for example, has a secret infrastructure that then you essentially deploy in Jenkins, put everything on the Jenkins file that tries to pull the secrets that are stored in Jenkins. Then there's also third-party solutions like HashiCorp's Vault. I don't know if you guys have heard of it. It's what they call the secret storage management system. You essentially say, these are all of my secrets. You put them on this container that's running Vault. and these people are authorized to read this. These people are authorized to change it, and so on and so forth. It is still complicated because it's hard to automate. You have this issue of you still need to authenticate this container, for example, with the container that contains the keys and the secrets that you want to store. And it gets tricky like that, but then, for example, container orchestration systems can help you do that. There's also this whole line of hype that's coming out with the GitOps. I don't know if you've heard of it. Which essentially everything is checked into Git, and everything happens by a push trigger. So you push into Git, and everything comes out of it, which is similar to what you were talking about. They have exactly this hiccup. How do you manage secrets?
Right.
And it's generally, there's a pre-deployed thing manually somewhere that can pull from Git and do everything and then inject secrets somehow. That's pretty much if you guys start looking and thinking of something to tap in and have a really good market share, is exactly this problem. I don't think there's many good user-friendly solutions to actually provide secret storage and management and authentication just out of the box.
Sort of riffing on that, I've noticed that companies that I've worked at that have tried to implement all of the cloud-native best practices, they essentially end up having a company within the company that's making sure that they're maintaining best practice everywhere. What you see is because I know AWS, for example, is trying really hard to integrate as many of these things into their own internal product in a way that's transparent mostly to developers, that they don't have to know any of this stuff. But do you see that as sort of being the future, or that companies themselves are going to have to implement all of these things themselves?
So that's a very good question. That's very personal opinion. I feel that the cloud native has a very good definition of what should be inside of cloud native, but there's not a lot of work on what's the scaffolding that goes under it. And I think that's exactly what you're saying. There's a lot of work in host configuration managers like Ansible and all of this. But in reality, I don't think the cloud native community really acknowledges that those things also need to be standardized and pushed for and identified and shared. I think over time that will start to stink more, and people will start noticing that needs to be tapped into. But for now, I think we're still in this phase of everyone has their own homebrewed solution, and I don't think it's going to change in the short term. Specifically because there's a lot of market for doing this top part first and doing it right, which, I don't know, it's still, it's still changing so much.
So the issue here you guys are discussing is the cloud is saying we're going to manage your infrastructure for you, I understand it. But who's going to manage putting your stuff up into the cloud? That can't be in the cloud, right? The way you push to the cloud.
Exactly. And for example, AWS, that's a good example. How are they managing their infrastructure? And if they want to put their infrastructure as a cloud native too, then what's under it now?
Yeah.
So it's
now you have to put the stuff in the cloud. That should be automated, but that can't be in the cloud.
Because it's the cloud.
Clouds all the way up instead of turtles all the way down.
Yeah, exactly. So it's a tricky problem. I don't know. I don't think it's going to be fixed soon, but it's going to start becoming a bigger issue later down the line.
It's just because you see Microsoft acquiring GitHub. AWS already has a Git repository service kind of thing. It just seems that more and more of the pipeline that you've described is pushing up into the cloud, which is arguably better for companies.
Yeah, that's part of the goal with GitOps and all of this. It's essentially everything is within the cloud. But then, again, I work with Arch, and we have what's a Git repository for the infrastructure. So you need to put that thing in to actually deploy all of our servers and all of the infrastructure that we have. But you can put that thing in the cloud because that's essentially, later we're going to put another layer on top of it.
Any more questions today? All right, well, thank you, Santiago.
No problem.